Good morning students. In this video we will discuss about 3D lines. So far I have completed DRs and DCs and 3D plane. Today we will see 3D lines. Today's topic is 3D lines. What is this? It is three-dimensional geometry. So three-dimensional geometry and vector algebra both should be studied simultaneously. Okay? Let us see 3D lines. So we will see these concepts points wise. Firstly, if a line is given, say first concept, this is a line, 3D line in space. This line is passing through the point x1, y1, z1 and drs of this line a comma b comma c. If a point on the line and drs are given, then equation of line is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the equation of 3D line. Equation of line. This should be applied when a point and drs are given. Drs in Cartesian system are similar to vector, parallel vector in vector algebra. So what is this? This is a line. Line is passing through this point and drs of the line are a comma b comma c. There is a formula in vector algebra. If I denote this point by a bar, it is a point, that is position vector of a point. And what is ABC? ABC is a parallel vector. I shall denote this by b bar. Then in vector algebra we have a formula. Vector equation of line passing through a bar parallel to b bar. What was that? R bar is equal to a bar plus t into b bar. So both are same. What is this? This is vector equation and this is its Cartesian equation. So when you study about these 3D lines, already I said you should go simultaneously. For the same concept, this is Cartesian equation, this is vector equation. So if you want, you can transform them. See now, here this is Cartesian equation where x, y, z are variables. Here it is vector equation, r bar is a variable vector. Whenever you want Cartesian equation of a vector equation, you are supposed to eliminate the vectors. R bar is always, what is R bar? R bar is a variable vector, xi plus yj plus zk. What is a bar? A bar is this point here. If I write in vectors, this will be x1i plus y1j plus z1k plus we have t into b bar. What is b bar? Parallel vector. If I take in vectors, this is ai plus bj plus ck. Okay, to get its Cartesian equation, just you remove ijk, vectors, unit vectors. So what is I coefficient here? It is x. Here what is I coefficient? x1 is there as well as at is also there. Similarly, if you compare j coefficients, left side y is there and right side y1 plus bt and z is equal to similarly z1 plus ct. So from this I will separate t value. This can be written as x minus x1 first. Write x1 on left side, then you also write a on left side, it divides. What is the value? T. Similarly, from this, y minus y1 by b is also t. Z minus z1 by c is also t. All these are t values. Therefore, I can write those are equal. X minus x1 by a is t. Also, y minus y1 by b is also t. Z minus z1 by c is also t. Therefore, there is no vector now. Therefore, this is what? This is Cartesian equation, which is in terms of x, y, z. Yes. Similarly, if this is given, you can find it Cartesian form. If Cartesian form is given, you can also transform it into vectors. So for every concept, there will be two approaches, vector approach and Cartesian approach. You are supposed to go simultaneously. So this is first one, vector equation of a line passing through a point parallel to vector is this. It's Cartesian equation. In Cartesian equation, this is a line passing through this point and having drs a, b, c. Yes. Then next point, second point. Listen, Nana. Point number 2. If a line is given, again this is a line which is passing through the point x1, y1, z1, and DCs of this line, DCs of the line are L comma M comma N. If these are DCs, in the first one point was given and DRs were given. Now DCs are given. What are DCs? They are DRs only, special DRs. Therefore, when a point and DCs are given, then also you can apply first formula. So using that, what will be the Cartesian equation? X minus x1 by L is equal to y minus y1 by M equal to z minus z1 by M. So this is the equation of the line. This form of line is known as symmetric form. What does it mean? First two formulas, they are applicable when a point is given and either DRs or DCs. Anything, either DRs are given, DCs are given, you can write the line in this fashion. Both are same, of course. All the DCs are DRs only. Next we will see another, number 3. What is number 3? A line is given. Say this is a line in space. The line is passing through 2 points now, x1, y1, z1, and another point x2, y2, z2. These are the 2 points on the line. When 2 points are given, the equation of the line is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equals to z minus z1 by z2 minus z1. This should be applied when 2 points are given. Line passing through 2 points. Yes. This is how I wrote this. I have taken a point to this point. I used first formula only. What is first one? X minus x1 by a, y minus y1 by b, z minus z1 by c. Where a, b, c were DRs, no? So we have 2 points on the line. When you have 2 points, you can write DRs. What are the DRs? x2 minus x1, y2 minus y1, z2 minus z1. That's what I have written here. So this is equation, Cartesian equation of a line passing through 2 points. Okay, these are 2 points now. If I suppose first point is a bar and the second point is b bar, we can also write its vector equation. In this case, vector equation will be r bar is equal to 1 minus t into a bar plus t into b bar. This is the equation, vector equation of the line. Proofs are very simple. You can refer your books. So for this line passing through 2 points, this is vector equation where t is a real number, any scalar, and this is their Cartesian equation. In the same, if you want, you can transform this into this. You can also transform this into this. Finally, whenever you want Cartesian equation of a vector equation, simply put r bar is equal to xi plus yj plus zk and you eliminate ijk. Then automatically you will be getting an equation in xyz only, which will be the Cartesian equation. So this is line passing through 2 points. Yes. Next, number 4. See now. Next, fourth point. So in 3D coordinate system we have 3 lines now, mutually perpendicular lines. This is x-axis, this is y-axis, and this is z-axis. Their intersection is origin. What about this? This is x-axis. X-axis means it is also a line. So it will have some equation now. In geometry, every curve is a locus. Straight line, pair of lines, circle, parabola, ellipse, hyperbola, all the curves are locus. Locus means set of points satisfying some condition. So here x-axis is also a line. So every curve, every line is a locus. Locus means that represents a set of points satisfying some conditions. The condition only its equation. What is this? This is x-axis. So if you take, there will be infinite points on this line, this locus. All those points will be satisfying same condition. If you take x-axis, if you take points on this, points are of which form? 1, 0, 0, 2, 0, 0, 3, 0, 0. If you take negative x-axis, minus 1, 0, 0, etc. What is your observation? For all the points on x-axis, their y-coordinates are zeros and z-coordinates are zeros. That is the condition. Condition itself is equation. Therefore, equation of x-axis is y equal to 0, z equal to 0. This is the equation of x-axis. Similarly, what will be the equation of y-axis? Z equal to 0 and x equal to 0. Z-axis equation is x equal to 0 and y equal to 0. So these are the equations of x-axis. Equation of x-axis, y equal to 0, z equal to 0. Equation of this, what is this? Y-axis, x equal to 0, z equal to 0. So I am denoting here x-axis. This is a line by 2 equations. Why 2 equations? These 2 equations they are planes. Always 2 planes will decide a line. In the planes chapter we have seen intersection of 2 planes is what? Their common portion is a line. So therefore always 2 planes will decide a line. So this is the line decided by these 2 planes. See, y equal to 0, y equal to 0 in the last video we have seen. It is equation of xz plane, zx plane, this one. Z equal to 0 is this xy plane. In xy plane, if you take any point, their z coordinates will be 0. That is the condition for all the points on xy plane. Therefore, entire plane's equation is this z equal to 0. This is zx plane, no, y equal to 0. This and this, they are deciding this line. That's why 2 equations. So no confusion. For a line I wrote 2 equations because 2 planes will decide a line. So therefore this is equation of x-axis, equation of y-axis and equation of z-axis. Yes. Next point number 5. See Nana. Point number 5. What is this point number 5? Parametric form. Parametric form of a line. Yes. We have seen this line just now. This is a line passing through a point x1, y1, z1 and which has DCs L, M, N. Then equation of this line is x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. What is this? This is equation of the line passing through x1, y1, z1 point and having DCs L, M, N. So these three are equal, no? I will suppose they are equal to R. Say they are equal to R. From this, by taking first and last, what I can write? X minus x1 by L is equal to R. Implies, if I write R on the right side, it becomes LR. Also, I will write x1 on right side. So, I will get x equal to x1 plus LR. Similarly, by taking second and last, y minus y1 by M is also R. This implies y is equal to y1 plus mr. Also by taking this and this, so z minus z1 by n is also r, implies z is equal to z1 plus nr. So from this symmetric form, by taking these are equal to r is a parameter, then I obtained these three equations. Which equations? Three equations. X equal to x1 plus LR, y is equal to y1 plus mr, z is equal to z1 plus nr. So these three equations, these are known as parametric equations of a line. Parametric equations of a line. So these are three xyz values. They are in terms of x1, y1, z1, lmn and r. x1, y1, z1 is given point through the line is passing. lmn are direction cosines, and what is r is parameter. What this r says, here you please see, if you take these values and if you form a point, what is x? X is x1 plus LR, y is y1 plus mr, and z is z1 plus nr. If you form a point with these three quantities, say I shall denote this point by capital P. If I take these parametric equations in the point form, then this will be representing all the points on this line, including this. What is this? This is a line. Line means it is a locus. There will be many points on this. So this is general point on this. This is obtained from parametric form. Therefore, this point will represent all the points on this line for different values of parameter r. If you take r is equal to 0, what you get? If r is 0, it will be only x1, y1, z1, this point. If I take r is equal to 0, if I take r is equal to 1, I will get another point, plus 1, plus 2, 1 by 2, 3 by 2, minus 1, minus 2, etc. Therefore, here r is a parameter. So what is this? This is x comma y comma z, x comma y comma z. the line's equation is in the variables xyz. What xyz indicates? Xyz, they are variables, therefore they represent a general point, therefore this is a general point. It can be anywhere on this, including at this. So for example, if I denote this point by A, this will represent all the points. If you take r is equal to 0, this will be equal to A only. That is, if you take r is equal to 0, this is x1, y1, z1 means same point. R equal to 0 means the distance between this point and P point is 0. That's why we are getting this. So this value will be R. What is parameter? Parameter indicates the distance of the point which you are finding. It's the distance from the given point. So this is the AP distance. If you take R equal to 0, R equal to 0 means this will be coming here. That's why only you are getting x1, y1, z1. Therefore here what is R? R is distance, no? So I will take mod. So mod R is distance. Mod R is distance between given point A and general point P. So this is about parametric equation. Generally this will be used when you have to find a point on a given line at a given distance from a fixed point. Yes. Point number 6. See now. Point number 6. If two lines are given, if x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C, or A1, B1, C1. This is one line. And another line is given, x minus x2 by A2, y minus y2 by B2, and z minus z2 divided by C2. These are the two lines which are in symmetric form, of course. If these are two lines and theta is angle between them. Theta is angle between them. Yes, these are the two lines, angle between them is theta. Then how to find cos theta? Very simple. These are what? Two lines. We have already seen angle between two lines in DRs and DCs. Angle can be found when you have DRs or DCs. So once again I am repeating, I am reminding that for first line these are the DRs. Second line those are the DRs. Angle between them is theta. Therefore what is formula here? Cos theta equal to A1 A2 plus B1 B2 plus C1 C2 divided by root over A1 square plus B1 square plus C1 square into root over A2 square plus B2 square plus C2 square. So for this also vector form will be there in dot product. If two vectors are given, then their dot product is A dot B. There we have defined cos theta. What was cos theta there? Cos theta is equal to A bar dot B bar divided by magnitude of A bar into magnitude of B bar. Already I explained this in vector DRs and DCs. Yes, this and this both are same. Here vector means here DRs. Another vector, another triad of DRs. A dot B means dot product of those two, A1, A2, B1, B2, C1, C2. Magnitude of A bar, its magnitude of B bar is this. So this is angle between two lines when you know DRs. This is also applicable when you have DCs. What are DCs? They are basically DRs only. Therefore, this can be applied to that also. Okay, see. Already we have seen this in DRs and DCs. If angle between two lines is 0 degrees, if theta equal to 0 degrees, then the lines will be parallel to each other. Lines are parallel. Lines are parallel to each other. If you write theta equal to 0 in this, and if you complete the simplification, then you will be getting the condition A1 by A2 equal to B1 by B2 equal to C1 by C2. Already seen this, Nana. So this is condition for two lines to be parallel. Next, if theta is equal to 90 degrees, if theta equal to 90 degrees, then the lines are perpendicular to each other. Lines are perpendicular to each other. If you write 90 here, cos 90 0, cross multiplication, this becomes 0, you will have only this. Therefore, condition for perpendicularity of two lines A1 A2 B1 B2 plus C1 C2 equal to 0. Yes. So this is the way of finding angle between two lines. When DRs are available, you can find also for DCs also you can find the angle. This is condition for parallelism. This is condition for perpendicularity of two lines. In the point number 6, we have seen angle between two lines. Very simple. Now, next point number 7. This is most important. Listen carefully. Here in this point we will discuss about the angle between a line and a plane. Angle between line and a plane. Yes. So angle between line and plane. Yes. For this discussion I will take a line. Okay. X minus x1 by L, y minus y1 by M, z minus z1 by N. What is this? This is a line. Next I will take the equation. I will take a plane. I shall take in general form. So what is this? This is a plane. So here we have to find angle between line and plane. Yes. So whenever we discuss about angle in from lower classes also, from high school, angle is defined for two rays basically. Angle is measured between two rays or even two lines. Angle is calculated between two lines only. For curves, angle is not defined. In specified cases, angle between curves will be defined. For example, if you take circles, angle between two circles. What is angle between two circles? Angle between their tangents at a point of intersection. So, angle between circles is angle between tangents. In the previous chapter, planes. What is angle between two planes? Angle between their normals. That means always angle is defined for two lines only. But here a plane and a line given. So I shall take this. So here formula, we are preparing a formula. That is not important. Concept is important. How to find angle between a line and a plane. Yes. This is a plane and a line is given now. Say this is a line. Like this. If this is a plane and this is a line, it will be reaching the plane like this. So angle between line and plane means this angle between line and plane. I will draw a line here parallel to on the plane. So this is angle between line and plane. Yes. This is to be found theta. But angle between, this is what? This is a line and this is a plane. Generally angle is found between two lines. Okay. For every plane, we know that there is a line called normal, which is perpendicular to plane. What is this? This is normal of the plane. So, if this angle is theta, what is this given line? It is a line. What is this normal? It is also a line. For two lines, angle is defined. Angle can be found. So, for the given line, from the equation, what are DCs? DCs are LMN. Every DC is DR only. DCs means basically they are DRs only. From the equation of the plane, I said XYZ coefficients are DRs of its normal. Therefore, for this line, this normal line, what are the DRs? A comma B comma C. Okay. So we need to find theta, which is angle between line and plane. What I do? This is theta, no? And what is this? This is a perpendicular right angle. I will calculate this angle. I will suppose it is x. So x plus, what is this angle? Theta. And what is this? 90. They are angles in a triangle. Their sum should be 180. From this I will separate x. 90 becomes minus, no? 90 and theta becomes 90. So what is this angle? It is 90 minus theta. So these are two lines with DRs, ABC and LMN. Once again, these are DCs, but DCs are nothing but DRs only. So for two lines we have DC DRs, therefore I can apply cos theta. For two lines, angle between two lines we have cos theta. Here angle between two lines is what? 90 minus theta is equal to A1 A2, that means A into L, B into M, C into N divided by root over L square plus M square plus N square into root over A square plus B square plus C square. So what is this on the left side? Cos 90 minus theta, which is sin theta. Sin theta equal to AL plus BM plus CN divided by root over L square plus M square plus N square into root over A square plus B square plus C square. So this is formula to find angle between a line and a plane. Yes, once again, here concept is important. This is what angle between a line and a plane. What is there on the right side? What is this actually? Old formula only. For this and this we have applied A1 A2 plus B1 B2 plus C1 C2 by under root of A1 square B1 square C1 square root over A2 square B2 square C2 square. Same old cos theta formula only, but in case of a line and plane, when you are finding angle between them theta, the formula changes like this. In general, for lines what will be there? Cos will be there. When a line and plane are given, right side formula is same, left side what comes? Sin theta will be there. So this is angle between a line and plane. Yes, once again, two lines are said to be coplanar if they are either parallel or intersect. This is the point to remember. Whenever two lines intersect, they will be coplanar. When two lines are parallel, they are definitely coplanar. What is second one? Opposite to this. If two lines are neither parallel nor intersect, then they are non-coplanar. Such lines are called skew lines. Such lines are called skew lines. So we have seen skew lines in vector algebra. So here I will discuss that only. For example, if two lines are given like this, R bar is equal to A bar plus T into B bar. This is a line. And another line, R bar is equal to C bar plus some S into D bar. This is another line. These are two lines. These are two lines. Yes. What the first equation says, this is equation of a line passing through the point A bar. This is point. And parallel to the vector B bar. This is point, this is vector. And the second line is, this is representing a line passing through the point C bar. This is point and this is parallel vector. If these two lines are neither parallel nor intersect, then they are non-coplanar vectors and they are said to be skew lines. For two skew lines, we will find the shortest distance. Listen. Shortest distance between the skew lines. These are two skew lines. Shortest distance between skew lines. Very simple. This is what magnitude of box of A bar minus C bar. A bar is a point on the first line. C bar is a point on the second line. And parallel vector to first line, parallel vector to second line. By joining the 2 points, point A is point on first line, C is on second line. If you join those two, you will be getting a vector. That's what I wrote here. So A minus C BD divided by magnitude of B bar cross D bar. Yes. This is distance between, shortest distance between two skew lines. This can be applied when the equations of skew lines are given in vector algebra, vector system, or also even for the Cartesian system. What is to be how to find this? Very simple. If Cartesian equations are given, Cartesian equation will be x minus x1 by a, like that, no? Easily you can pick a point from the numerator, x1, y1, z1. In the denominator, drs will be there. That will be a vector parallel to first line. Point on first line, parallel vector to first line. Similarly, from second equation, second point and second parallel vector, you will get A bar, B bar, C bar, D bar. In A bar, C bar are points on the lines, B bar, D bar are parallel vectors, that is drs. Finding this. So this is shortest distance between skew lines. So these are some of the important properties of 3D lines. So I have completed, I made videos on DRs and DCs, 3D plane and 3D lines. So you should study all three together, and this 3D geometry should be studied simultaneously with vector algebra. So in next video, we will discuss the problems on 3D geometry. Thank you.